Okay, we're doing question 5. See, doing question 5, right? The entire question reads as follows. The graphs of f of x equal to x squared minus 4 and g of x equal to negative x plus 2 are sketched below. A and B are the x-intercepts of f. C and D are the y-intercepts of f and g respectively. K is a point on G such that BK is parallel to the x-axis. Right, let me stop right there. K is a point on G such that BK is parallel to the x-axis. That is bullshit. It's incorrect. It's totally wrong. Utterly wrong. BK is parallel to the y-axis. Right, let me write it down. BK is parallel to the y-axis. The only relationship BK has with the x-axis is the mere fact that BK is perpendicular to the x-axis, right? So BK is perpendicular to the x-axis. That's the only relationship they have. F and G intersect at A and E. So we already know that F and G are equal. F, right? Let me write it down. F is equal to G of x at A and E. Remember, before you go to the questions, you read the entire statement. And then you can proceed to the questions, right? But before you do all of that, you need to read the statement. That's where the answers are, especially in Euclidean geometry or analytical geometry. The answers are in the statement. As soon as you skip the statement because you're trying to be smart, you will fail dismally. So let's go on to 5.1. It says write down the coordinates of C. So these idiots are saying write down the coordinates of C primarily because you just have to look at your graph and then you'll be able to identify the coordinates of C. That's how easy it is. So you can see that C is actually a turning point and C is actually at the line x is equal to 0. That's the line. Remember, the vertical axis, the y-axis is the line x is equal to 0. So you know the x coordinate is already 0 there because it's on the line x is equal to 0. That's the equation of the line. And as for the coordinate of C, right, how do you determine it? You already have the x coordinate, right? And usually, since C is a turning point, you would use this formulae. I'm not going to write the second one. I'm just going to write the first one, right? Because the second one is out of your reach for now. It's negative b over 2a. This is the formula that you would use to get the x coordinate of the turning point, which is 0 in this case. So to get C, you just punch in into the calculator. You actually copy the equation, right? And then punch the value in your calculator to get this. Wherever there is x, you put 0 plus, minus 4. So your f of 0 is equal to negative 4. Therefore, your coordinates is 0 to negative 4. Right, that's how you determine the coordinates of C. Therefore, C is 0, semicolon, negative 4. So these idiots are still saying, write down the coordinates of D. So I guess they're giving everybody free marks, just free. They're giving everybody a break, I guess. So let's look at D. I see. D is actually still on the line x is equal to 0, the vertical axis. That's where D is. So how do you determine D, right? It's quite simple. So D is a point on the function g of x, the linear function, right? And it's also the point on the y-axis, right? So this is the standard form of a linear function plus c. Your c is the y-intercept, right? And your c in this case is equal to 2, and that 2 happens to be the y-intercept, right? So you know that at the line, still the same thing applies, right? At the line, x is equal to 0, the y-axis, I'm talking about the y-axis, x will always be equal to 0. So we know that we have 0, and then we know that our y-intercept is 2, right? So they were just asking about the y-intercept, but these idiots are trying to be smart, so they do what they do. So the third question says, wait, that was 5.2. The third question says, determine the length of CD. Right, this is interesting. I like this entire question because it's going to teach you a lot of tricks, right? This is just amazing, big time. So listen, bruv. We are talking about a vertical distance here. It's a straight vertical distance, right? And your length will always be positive. That's one thing that you need to understand. Your length will always be positive. No matter where you go, geometry or wherever, your fucking length is positive as fuck. So let's go to this question and attempt it. We know from O to C is actually 4 units, right? And we know from O to D we have, what was that? Well, it was 2 units, right? It's a build up. Do you remember when I told you that if these effing idiots ask you a question about anything, you kind of have to use that question later on. They don't tell you this, but everything that they ask you or tell you in the statement is for your own benefit. They're asking you because they want you to use this. That's why if you fuck up the first question, your life is ruined. You might as well give up. I'm joking, you don't have to give up, right? But you keep moving on. That's life. But my point is, the first question they normally ask leads to the second question. It's a build up. That's how these fucking idiots roll. So we know that OD is 2 units, but the distance from CD is equal to 4 plus 2, which is equal to 6 units. We're talking about units here, so ignore the signs. We don't care about the signs, bruv. We don't care. We just don't care. So 5.4, calculate the coordinates of B. Right. Quite simple. Quite simple. Right. What do we know about B? B is actually the roots. B and A are the roots of the parabola. B and A are the roots, x-intercepts, or zeros of the parabola. So let's do this. It's actually 3 marks because you have to solve something there. So we know your f of x is equal to this, x squared minus 4. Then this is equal to 0 because we're talking about your x-intercepts, your zeros here. We transpose 4, then we use the square root. X is equal to plus or minus 2. See, never forget the plus or minus 2, because whenever you're using the square root, that means you have 2 possible solutions, 2 possible roots, 2 possible zeros. That's what you have. That's the result whenever you use the square root. So the first x-intercept is equal to -2, and the second one is actually equal to 2. But as you can see, B is actually in the second and third quadrant. So any value that's going to be attributed to B is actually so effing negative. It's negative as hell. So we have -2 semicolon. Again, note this every time we are on the line y is equal to 0. That is what the x-axis is called. As a matter of fact, from today onwards, never call the x-axis the x-axis. Whenever you see the x-axis, call it the line y is equal to 0. That equation is going to help you forever. The y-axis is the line x is equal to 0. So it's sort of inverses. That's what we're talking about here, bruv. So, bruv, let's move on. We know our y is 0 there because we are on the line y is equal to 0, which is the x-axis. We've got B, so we move on. 5.5. Determine the coordinates of E, a point of intersection of F and G. Interesting. I love this question very much. So I told you this, right? It was in the statement. They told you that A and what was that? It was E and A, right? They told us in the statement that E and A are the points of intersection. So we know that whenever we have something or two things, whenever we have two things, two functions intersecting, they will always be equal at that point. So we know f of x is equal to g of x. We have our notation right there, and we know the equation of f of x is equal to x squared minus 4, which is equal to negative x plus 2. We solve this algebraically. X squared plus x. I moved x to the left side, right? That's what I did. And then negative 4, we move 2 to this side. If negative 2 equal to 0, x squared plus x minus 6 equal to 0. Yes, okay. I'm gonna show you a way to factorize. I'm a fucking smart ass, so I don't like taking the longer route, thinking outside the box. Shorter methods work and they help you save time. So okay, I'm not gonna introduce you to this. Why? Because you haven't done the quadratic equation formula yet. So you need to do the quadratic equation formula. So you can factorize this your own way, and then I'll tell you about the quadratic formula method when you get to grade 11 next year. So let's forget that. So we're going to have x minus 2. Those are the factors. And then we have x plus 3, right? So x plus 3. So x is equal to 2 or x is equal to -3. So whenever you're dealing with an equation, always put these values back right there, right? Put your x is equal to 2 wherever there is x, put 2, and you will get 0. That's why we're saying your x-intercepts are your zeros, because they give you 0. They are your zeros, your roots, your x-intercepts. So if you plug in 2 right there in this equation, you'll get 0. If you plug in -3 in this equation, you'll get 0. If you do not get 0, your answer is wrong. Just know you did something wrong. You did something terribly wrong. You did something, you get the picture, right? So anyway, that is correct. Let me check. Let me punch in 2. Yes, I get 0. Even if I do the same thing for 3, I get 0. -3 actually. Sorry about that. Yeah, I still get 0. So yeah. So we want the coordinates of the point of intersection of f and g at E. we see that E is actually in the second and third quadrant. So this is not gonna be a true value for E. So E is -3. If you want the Y value, you put. So now we're gonna look for the Y value. Excuse me. So for the Y value, we pick the. You can go for the quadratic equation or the linear equation. I like the linear equation because it's quite simple. It's not gonna be complicated. It's not gonna bring any drama. So we plug in -3 plus 2, right? That is plus 2. So E is, these are the coordinates of E. This is going to be 3 plus 2, that's 5. It makes sense because E has to be 5. Remember, D was 2, so E is actually on top of D by some units, you know. So E is 5, I understand. This is understandable, right? So let's go to 5.6. Interesting questions. Okay, I had to redraw the graph because we are doing graph interpretation. You have to see everything and it's all laid out like that. Right, so 5.6.1, they want the values for which f of x is less than g of x. So in this case, f of x is less than g of x. I've told you this before. When they ask you this kind of a question, they want where f of x is actually below g of x. So let's go to our graph. I tried by all means to redraw it beautifully. So I'm gonna use, let me use my calculator this time around. Right, okay. I'm blocking out this side. Look at me, right? Okay. I'm moving the calculator to the positive side. You see nothing here, right? There's nothing, absolutely nothing. So we move, and then all of a sudden we start seeing the graph of G is going up there up until if infinity. It goes on and on and on and on forever, for millions and millions of years. And then we see the parabola, and then boom, we see something there, right? We see an intersection, right? But we're not interested in the intersection because we are required to find where it's less than, not equal to. There's no, it's not this, right? So there's nothing that says equal to. So we want where it's below, not where it's equal to. Here is actually equal to, right? After it's equal to, it starts being, after it's equal to, right? Once we move, then the linear function is on top, right? It's on top. When I say on top, remember with functions, we're talking about x and y values. That's all we talk about. I'm not saying it looks above, right? I'm not saying it's above. We don't do that. It's mathematically incorrect and it's disgusting. We are talking about the y values here. So the y values are actually bigger for the linear function, and for the parabola they are getting less. So the linear function, right, we're still here. Don't focus on the other side. The linear function is on top because the y value here is bigger than the y value of the parabola, you know, up until the turning point going upwards. So let's mark this. This is where it starts happening, right? The dotted line, I'm gonna put it right there. So starting at E, we see the linear function being on top and the parabola being below, which is exactly what the condition states. And then we move on. But it's what we want is still happening. So we're having a party here. So it's all good. We're having a good time. We're seeing what we want to see, right? Boo, boo. boom. And then all of a sudden, something happens. We see the intersection of our parabola and linear function. And then the parabola decreases, right? And then, no, excuse me, the linear function decreases while the parabola goes up. So we're also here, right? And then this is the region that we want. Okay, let me mess up my graph. So this is the region that we're talking about, right? Excuse me, right here. Start from everything that is right here. Remember, we stop at the dotted line. The dotted line tells us to stop. So this is the region that we want for the condition, right? So how do we explain this mathematically? We say this happens where x is an element of, we use the parentheses, the curly brackets, y, because at this point, E, the two graphs are equal, they intersect, they touch, but we don't want a case where they're equal. We want a case where f of x is actually below, right? So we will not include this, we will exclude it. It starts right there at point E. Let me check the coordinates of E again. X at E is actually -3. It happens up until the point A. A was 2, remember. This A was the second root. It was the second 0, the second x-intercept, which was 2, right? And it's also the intersection of g of x and f of x. So it happens at A again, so at 2. And then we use the parentheses again because we are not interested in the case where the two graphs meet. So we have to exclude 2. It's not part of the picture. If they said where is below and also equal to, we would include it, right? So this is the interval notation. Let's use the set builder notation. So we'll say x, right? So this, you have to watch out for this. It's actually interesting. I almost said tricky. So when we move to this point, starting from E, right? This is the dotted line, moving from that point, going that way. What is happening to our values, right? The values are increasing. So x is greater than what? -3. Bear in mind, we're not using this x is greater than or equal to, because we don't want that. We want where it's actually less than. That's why we're using this. And then if let's start here at point A, where the dotted line is, what are we doing when we move to this point? What's happening to our x values? Our x values are decreasing. So x is less. We say less because our x values are decreasing from this direction, going this way, right? So we say less than 2. So these are the two possible answers. Usually I preferred the interval notation whenever there was something related to a graph, whether I had to deal with exponential equations, when inequalities. Whenever I had to deal with inequalities, I would always use the interval notation. It's quite easy to understand. This, you have to analyze the graph. Like I hate it. So let's go to 6.2, right? So we want f of x multiplied by g of x less than, right? Yeah, I didn't see the question correctly there. It's not less than, it's greater than. I just checked again. It's greater than or equal to 0. Right. This is an interesting case. So let's interpret our graph. Okay. So let's go to our graph. Let me explain this case. So they are saying here, right, your f of x has to be above the x-axis. The plus sign means above the x-axis because everything, the y value above the x-axis is, the y value is above the x-axis. They're all positive as hell. So your g of x also has to be above the x-axis. Just like I said a few seconds ago, every y value above the x-axis is positive as hell. There's nothing more positive than that. So we multiply this because there's a multiplication sign there. We multiply this. This will give you a positive. So this is what it means, right? Or we could look for where f of x is below, and also where g of x is below. The negative sign means below. Remember, we're talking about y values. F of x is a y value. G of x is a y value. This is y times y, right? So we could go for this. A negative times a negative is equal to positive. So the condition still applies, right? So let's go to our graph. We start here, right? You don't see anything over there. Like, close your eyes here. Don't look at this. Let's move our calculator. And then boom, all of a sudden I see the linear function, right? And the effing parabola. So I'm like, okay, I see something here. So we're having a good time. And then all of a sudden your parabola goes down, right? At point B. So we no longer have the condition, right? We had it up to this point. See, I'm marking, there's a dotted line in B, coordinate B. So I'm putting a dotted line. Do you see that? I know it's messy, but you have to open your eyes. Right there, I'm putting a dotted line. So our parabola, it goes down below the x-axis. So our y values are becoming negative here, negative and negative. So this happens from negative infinity, right? It happens forever because there are arrows there. It happens forever, and it stops right here at point B. The y values of the parabola become negative at point B, while the y values of the linear function are still effing positive, right? So we stop there. That's my dotted line right there. We stop here. We hold it, right? So we put it down. We say it happens where x is an element of negative infinity, because it starts from negative infinity, right? And then it stops at B, right? But we're using these parentheses. Actually, in this case, we've used one curly bracket. I'm using this curly bracket because graphs, there's nothing, there's no function. It doesn't fucking exist. No function will ever touch infinity. It's fucking impossible. You just can't touch infinity if you're a function. There's nothing that can touch infinity. Nothing is impossible, right? So we have negative infinity there. So we use curly brackets because nothing will ever touch infinity. Only God can touch infinity. So we move on. At point B, our x coordinate, our root there was -2. I remember properly, right? Ask yourself this: is the parabola at point B equal to the linear function? No effing way, they're not equal. So you cannot use the square brackets, because if you use the square brackets, you're saying they're equal at that point. And if they're equal at that point, you can actually use this and write it down, because the condition stipulates that right where they're equal and where they are above or below the x-axis at the same time. So we'll still use your parentheses here, because there's nothing, parentheses, curly brackets still, because guess what? Your parabola and your linear function, they're not fucking equal. So we move on. We go on, right? Let's go back to this. We were here. This is where it stopped. where the parabola becomes negative. I'm talking about its y values, right? Okay, bruv, we move and we move. The parabola is still negative. We don't want that, right? Remember, these two conditions, f of x multiplied by, g of x greater than, no, let me write below, f of x multiplied by g of x greater than 0, or your f of x multiplied by g of x greater or equal to 0. They mean that your two graphs have to be above the x-axis at the same time, or below the x-axis at the same time. That's what it means, right? At the same time. I hope you understood that. So we're still moving. We're here moving. Your y is still negative. Your linear function is positive as hell. Boop, 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 boop. Same thing, negative, positive. And then all of a sudden they meet there, right? They meet, and your after meeting, right, your, what the fuck is this? Your linear function becomes negative. I don't know why it's becoming negative, but then your parabola becomes positive. See, it's like they're going in opposite directions. It's effing weird, bruv. So after the intersection, we don't have our case anymore. But bear in mind, we also said where they're above or below the x-axis at the same time, or equal, right? There was equal included. So they're equal there at x is equal to 2. Remember, at point A, the coordinates are x is equal to 2 and y is 0. So union, right? You include this. Union means or. By writing that thing, looks like a U shape. Union means or. So we're saying it happens at x negative infinity up to negative 2, or we include the square brackets because it means equal to. Include means equal to at 2, right? Or you could just say or at x is equal to 2. They will give you a mark. You're still accurate as hell. Okay, let's use the, what the hell is this? The self-builder notation, the greater or equal to sign, right? So when you're moving this way, focus, right? This is the dotted line for point B, right? So our condition starts this way from the negative side. So when you're moving from the negative side, going this way, what is happening to your x values, right? Your x values are increasing. So your x value is increasing, it becomes greater. So this happens where x is greater than negative 2, because you're moving this way, right? You're moving this way, so your x values are increasing. So that's why you have a greater than sign, because greater means increasing, it's becoming greater. So your x values are increasing. This is your first piece, right? And then it goes on and 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 on at the same time. It also happens right there. We covered that up already. I'm not going to do the entire thing. At x is equal to, or x is equal to 2, right? So you could, this is answer number 1. This is answer number 2, right? Use whatever you prefer. Let's look at the last question. It says calculate the length of AK, right? Let me look at this. Calculate the length of AK. Interesting. So many ways you can do this. 4 marks, right? AK. We see that's a right angled triangle, right? So OB, the units from O to B are 2 units. Ignore the negative sign when we're talking about length. The units from A to O is actually 2 units. Therefore, you can say BA is equal to 4 units. BA is equal to 4 units, right? I'm still casting about in my mind for another way of doing this. I don't like the method I'm gonna use, using the Pythagoras theorem. So BA is 4 units. And KB, in order for us to find the length of KB, we just need to find the y coordinate of K, and we know K is in the function g of x is equal to negative x plus 2. We know K is actually a vertical line. KB is a vertical line. Let me tell you something. Listen properly. Listen to this. Listen very well. Vertical lines and horizontal lines. Points on a vertical line, they share the same x coordinate. Are you listening? Points on a vertical line, they share the same x coordinate. Write that down. I'm going to say it again. Points on a vertical line share the same x coordinate. Points on a vertical line share the same y coordinate. Points on a horizontal line share the same y coordinate. Let me prove it to you. See KB. KB shares the same x coordinate with, do see K? K shares the same x coordinate with B, right? And K, the x coordinate of K is -2. The x coordinate of B is -2. Look at point B and A. They are on the horizontal line. They share the same y coordinate. The y coordinate of B is 0. The y coordinate of A is 0. So take this down, write this down, write it on the side and keep it in your mind forever. Points on a vertical line share an x coordinate. Points on a horizontal line share a y coordinate. Right? So we want we want the distance of BK. To find the distance of BK, we just have to find the y coordinate of K, right? So, and we know that K is a point on the linear function, so we can use the linear function to find the y coordinate of K. We already know that K shares an x coordinate with B, and that x coordinate is 2. So we just plug in the value of 2 to get another value, which is y. Remember, for every x value, there's a y value. That's the definition of a function. That's why I'm doing this. So we're saying there's a value which is -2. There's an x coordinate, an x value which is -2, right? And it's on K, it's on point K. So in order to find its match, its y value, because x go with y, boys go with girls. It's nature, that's what it is. So x is a girl, y is a boy, so they match up, and then you'll have 4, right? So the BK g of x, which is y, which is the length right now, is equal to 4 units. And then we use the Pythagoras theorem. We know it's, what was that? Oh, it's AK squared, right? It's AK squared is equal to ABA squared and stuff plus BK squared. Then we have BA. What was BA? BA was 4 units squared. And then everything is 4 units. Crazy. This is 16 plus 16, that's 32. AK squared. Okay. What are the odds? 4. The hell, man. So square root of 32 square root of 32 is equal to 4 root 2. 4 root 2. And 4 root 2 is what? 5,65 6 units. Right. We're done. So yeah, let me post the video, bruv. It's 40 minutes because I was explaining. That's why it's 40 minutes. Let me upload it.